So welcome to the next chapter in the video. In this chapter, we're going to handle collision within our game. So I can see a preview here. I have collision working right here. And what's happening is our bullets are colliding with everything. When they collide with anything, they get destroyed. Whenever our obstacles collide with our player or collide with the opposite wall they spawn from, it shrinks our play field by a little bit. And we're allowed to now shoot our power-ups. And we don't really have functionality created for our power-ups yet, but we've created a temporary power-up function within our game manager. Whenever we want to get to what our power-up does, whenever we want to get to that, we'll be able to just jump right in and update our power-up function. Currently, right now, our power-up function just creates a debug.log message saying we've collected a power-up. So, we have gameplay going on now. Collision was the last step. And from here on out, after this video, it'll all be about refining the game, adding UI elements, adding gameplay elements, game mechanics, and further refining the balance of how the game is to be played. All right, so why don't we get into this chapter and figure out how we're going to do all this stuff. All right, so why don't we break down what we need to achieve real quickly. All right. So I'm going to bring in the outliner here, the notes I've made for this. And why don't we just break it down step by step? All right. The first thing we need to be able to achieve is obstacles. They need to cause a penalty and destroy themselves when they collide with the boundaries and the player. Okay. Obstacles need to ignore collision, though, when they spawn inside a boundary wall. So an obstacle that's traveling to the left, if it spawns in the right wall, it needs to avoid being destroyed within that wall. Otherwise, it'll never have a chance to travel out from it. Obstacles also need to be destroyed when they collide with bullets, but they will not incur a penalty when they're destroyed by bullets. Now let's look at power-ups. Power-ups need to cause a positive effect and be destroyed when they collide with a bullet or the player. And power-ups only need to be destroyed when they collide with the boundaries. And like obstacles, power-ups need to ignore the collision of the wall they spawn from. And for bullets just need to be destroyed when they collide with anything. All right? So those are our 6 main goals of our collision in this game. So how do we achieve this? Let me go make my timestamp. Well, we're going to achieve this by creating a collision script for obstacles. And this collision obstacle script is going to have 2 conditions. And these conditions are going to check if they've hit a boundary or player. And then they're going to call the penalty function from the game manager, the shrink function, and destroy themselves. This collision script for obstacles also going to have another condition that checks if it gets hit by a bullet. And if it gets hit by a bullet, it'll only destroy itself and not give a penalty here. And then we're going to create a collision script for our power-ups. And it's going to be much like our collision script for our obstacles up here, except the conditions will be a little bit different. It'll be checking if it hits a bullet or a player. And if it does hit a bullet or a player, it'll call a positive effect or a positivity function from the game manager, and then it'll destroy itself. And if it hits a boundary, then it just destroys itself and you don't get the positive effect. And then we're going to create a collision script for bullets right here. And the only thing bullets are going to do is ignore the player, and then if it hits anything other than the player, it's going to destroy itself. So that's what we're going to accomplish in this chapter right now. We've broken it out. It's really nice when you start getting into a mechanic in the game. You kind of just outline it like I did in the last 2 little sections there. So why don't we go ahead and get set up with our next part. We're going to start setting up our collider components so that we have, properties on our game objects in our game scene that will allow us to call code on them to begin coding our collisions. All right, so there's a checklist of things we're going to do, and we're going to look at each one of our prefabs separately, okay? And I'm going to go ahead and delete my player, and I'm going to bring my prefabs in one at a time to make sure that they're good. But before I hit my prefabs, I'm going to check my boundaries right here. I'm going to make sure that each one of my boundary walls, so my bottom wall, my top wall, my left wall, and right wall, I want them all to have a box collider. So I'm going to remove the box collider off of all of my elements, and you can select multiple game objects at a time and perform the same operation. So I've effectively just taken off the box collider on all of my boundaries. So possibly maybe you didn't have collision detection or collision boxes on here. Well, we're going to do that right now. We're going to go to my boundaries. I'm going to select all of my boundaries, and I've got them named logically right, left, top, and bottom. And with all of my boundary cubes walls selected, I'm going to go to my inspector over here on the right side of my screen, go to add component, go to physics, and I'm going to give them all box colliders, and I'm going to make sure is trigger is set to true. And then we can inspect our collider. There's two ways you can inspect your collider to make sure it's where you want it to be. You can either turn off your mesh renderer on your game object, and that'll just leave this green outline. This green outline you see right here, maybe it's a little hard to see since the ground is green, but this green outline is actually your collider box. So that looks good. And since our cubes are already kind of boxy, Unity went ahead and matched the exact dimensions. So our boundaries are taken care of right now. So I'm going to go ahead and save scene, save project. Next, I'm going to bring in my bullet. I'll just go right down my prefab list here. And I'm going to expand my bullet. And I need to do a few things to this bullet. All right. So my parent object, which is my main game object right here that everything is a child of, everything is nestled right underneath. The very top game object in my bullet prefab is called my parent object. I'll be using that terminology for the next few minutes, talking about what we need to add and take away from our objects here to prepare for collision. So my parent object in bullet only has a mover script on it. That's okay right now. If I go to my bullet mesh, maybe there was, okay, I think when you make a sphere, it automatically spawns with a sphere collider. We want to go to my bullet mesh, and we want to take off the sphere collider. We don't want it. So I'm going to go to remove component. All right, I'm removing that collider from the object itself. And the way I made my bullet mesh, or the way I scaled my bullet, was I scaled my bullet mesh by half in my transform. You can see it now. I've made my scale all ones on my bullet mesh object right here. So I'm going to undo that. It was 0.5, 0.5, 0.5. I'm going to make my scale of my mesh just zeroed and ones. I'm going to go to my bullet now. Now I'm going to add a physics sphere collider. I'm going to make is trigger true. And here I'm going to control the scale on the parent object here. So here's where I'm going to do 0.5, 0.5, 0.5. Well, why did I do that? All right, well, why don't I go ahead and show you why. I'm going to make my parent object normal scale, but I'm going to leave my sphere collider on my parent object. But now I'm going to go back to my mesh, 0.5, 0.5, 0.5. Now let's look at my collider. My collider is huge compared to the actual mesh of my object here. So that's definitely not what I want to do. So I'm going to resize my mesh back up to the normal. Now my collider is nestled right around my sphere. And look what I can do now. As I scale my parent object, my sphere collider scales with me. So that's the reason why I'm controlling my scale on my parent object rather than the bullet mesh child that is actually our mesh. All right, so now that we got that out of the way, we've added our sphere collider. Is trigger is set to true. I'm going to add another component. I'm going to go to add component physics, and I'm going to add a rigid body and uncheck gravity. A rigid body is necessary on one of the two objects that are colliding with one another in order for the on trigger enter command to work that we'll be using in our code. So at least one of the colliding objects has to have a rigid body. So I'm going to put rigid body on all the prefabs that move in my scene, and that should take care of everything. All right, so with bullet now having the correct collider and a rigid body, and I got the scale fixed, I'm going to go to my prefab section up here on my right-hand side of my inspector and hit apply. That will update my bullet prefab, and if I select my bullet prefab, you can now see I have the rigid body and the sphere collider attached. So with my bullet prefab updated, I can get rid of it. I'm going to bring in my obstacle next. And we got to do a lot of work to my obstacle. I'm going to go ahead and expand everything. And I got 3 different meshes right here, and they all have their own collider. We want to get rid of those colliders. We don't want any colliders on the actual meshes of our objects right now. So I'm going to remove that component, box collider. I'm going to move this component, box collider. So my fins no longer have colliders. And my capsule right here, I'm going to remove its collider. So I'm going to remove that component. Now I have no colliders on my obstacle anywhere, but I am going to add a collider to the parent object for my obstacle. Right here, the very top of object in my tree here. So with my obstacle parent object selected, I'm going to add component, physics, and I'm going to give this a capsule collider. And it might be a little hard to see what's going on here. I see maybe one little green ring. Well, I'm going to change its direction on the x-axis, and I'm going to increase its height. And there we can start to see my capsule collider. All right. And if you want a little bit more fine control over positioning, instead of having to just drag the radius and the height, you can actually click on Edit Collider in your inspector. And when you do that, little cubes or little squares appear alongside your collider. And if you're careful, you can select just that square, and you can start editing the dimensions of your collider using these little squares on my collider wireframe. All right, so I got my capsule collider positioned, and looks like it's a pretty good dimension. I'm also going to make sure that its trigger is checked to true on it. All right, that's looking good. And since this is a moving object in my scene, I'm going to make sure I have a physics rigid body component attached with gravity unchecked. Remember, one of the 2 colliding objects in a scene has to have a rigid body for our code to work. So I'm just putting rigid bodies on all moving objects in my scene. All right, so I have my collider and my rigid body. Everything looks good. I'm going to hit apply to update that prefab. Now I can get rid of it. Let's bring in my player. All right, so that's my player object right there. I'm going to expand it. And I have a few different meshes going on here. So my cube and cylinder that make up my object right here, they all have colliders on them. So I'm going to go ahead and get rid of those. Cube, box collider, get rid of that. Player mesh is okay. I'll just leave that the way it is. Bullet spawn point, it's fine. So now I'm with all the colliders on my meshes turned off or taken away. I'm just going to focus on my parent game object of my player. And now I'm just going to add components. I'm going to add a box collider to this. And I'm going to click on my edit collider button. And I'm going to pull out my collider so it kind of encompasses my little gun section right there. All right. After I'm done messing with the dimensions of my box collider, I'm going to check is trigger to true. Now I'm going to add well, you know what? I don't need to add a rigid body to this because it's not one of the moving objects in my scene. It kind of is since I'm having direct control over it, but I'm only putting those rigid bodies on spawned or obstacles that move with my mover function. It was just the easiest way for me to keep track of what has rigid bodies and what doesn't. I mean, you can add a rigid body to this. I think if both objects have rigid bodies, the collision will still work. But I'm not going to add any extra components that I don't need to, because everything colliding with my players, such as obstacles and power-ups, they're already going to have the rigid body, so I'm good there. I really just needed to add a box collider and set its trigger to true and get rid of all the other colliders that I didn't need that were attached to the meshes that made up this player object. So after all those changes are made, I'm going to hit apply on my prefab. There we go. Now I can get rid of the player. I'll bring him back in a second. And we got one more guy to take care of, which is my power up right here. I'm going to expand it. So we have two meshes right here. We're going to remove their capsule collider components. All right, so we don't have any colliders on the power up right now. And I'm actually going to give this a physics, I'm going to give this a box collider. All right, that shape is more or less a box. They don't have a plus sign collider. And a spherical collider, I guess, could work, but box is the simplest form. And I can actually increase the length by scrubbing on my size right here in my inspector. And I can increase the Z direction as well as the X. And roughly just get it to encompass the dimensions of my power up. And that looks pretty good. We're not going for total accuracy. Our game is simple enough where, you know, I don't think it's going to break the game if we collide with my plus sign right here on this corner. We'll call that okay. Before I'm done with this power up, I got to make sure the box collider is set. The is trigger of option right here is set to true. And I'm going to add a rigid body because this is one of the objects in my scene that has a mover script attached. Remember, all my movers will have their rigid bodies. So we'll go to physics, rigid body, turn off gravity, and update the prefab. So now all of my objects in my scene have proper colliders and proper rigid body components. So I'm going to bring my player back into the scene. Just want to test things, make sure I didn't break anything. All right, great. So everything's working pretty good so far. All right, great. So why don't we attack the easiest thing first? We're going to attack creating our bullets collision. This will be the easiest collider we'll make. So I'm going to go to my scripts folder, and I'm going to make a brand new C# script and call this collision bullet. Since I'm going to have multiple collision scripts, I'm going to call them collision first and then what they're colliding second. So all of my collision scripts will be alphabetically next to each other. So collision bullet. All right. Before I go into my collision bullet script, I'm actually going to apply that to my bullet prefab. So I'm going to go to my prefabs folder, select my bullet prefab, and then in my inspector, we're going to add component. We're going to go all the way down to the bottom to scripts, and we're going to add my collision bullet script to the inspector's components. All right. Now I can open up my collision bullet script and get into some of the code here. All right, I'm going to delete everything in here, and we're going to start fresh. All right, so we really only have to do one thing here. We need to call a void on trigger enter function, collider other. All right, so this function right here will test to see if an object enters the collision field of another object. And if it does, then we're going to define this variable other. We're going to assign what we're colliding with, the other object we're colliding with. We're going to assign its collider component to the variable other. All right, so then we'll create our brackets. So this allows us to see exactly what we're colliding with. And in this field, we need to check and see if the bullet is colliding with the player, because the bullet spawns inside of the player. I'll show you what happens if we don't account for that. So I'll just do a destroy game object. All right, because we want the bullet to be destroyed anytime it collides with anything. So really, that's all we need. So if I press play, let me fix the syntax error. Had an extra semicolon where I didn't need it. Got rid of it. Now I'll press play. Something's still up. And this is an interesting syntax error. Whenever I was calling the destroy function, I wanted to destroy the game object, the bullet that this collision bullet script will be attached to. But Unity went ahead and auto-corrected and gave me a capital G instead of a lowercase g. That little syntax error was throwing Unity off because This means whatever game object the script is attached to. This means I'm trying to declare, initialize a variable of type game object. So gotta love your syntax errors. Capitalization matters. All right. So I'm going along. I'm pressing spacebar. You can hear it, right? Nothing's happening. And why don't I don't know, why don't I get rid of the player, the cube, and mesh renderers? You can see that my bullet is spawning inside of my player and instantly being destroyed. So that's no good. So let's go back into my bullet collider script, and we have to make a condition. We have to say if other.tag is not equal to the tag player, then we can destroy. Then it's okay. So effectively what this does is whenever our bullet collides with something, it's going to check and see if the other thing we're colliding with, if its tag is not equal to player, then we'll destroy it. If it is equal to player, then we won't destroy anything, and the bullet will pass right through my player without being touched. There we go. And now you can see my bullets are being stopped by any game object in the scene here. Walls, obstacles, even power-ups are stopping it. And that's really what we want to have right now. All right. So how do we get my bullets to start destroying things? How do I get my boundaries to start destroying things? Well, why don't we tackle that next? All right. So why don't we get started with tackling object or obstacle collision? All right. So I'm going to make a new C# script here. I'm going to call this collision obstacle. All right. So there we go. I'm going to go to my prefabs folder, select my obstacle, go to my inspector, add component, go down to scripts, and add the collision obstacle script right there. Now I can go in and we can start coding what will happen whenever our obstacles collide with things. All right, so let me zoom in a little bit. I always keep forgetting to do that. All right, actually, I'm gonna just get rid of all this junk right here. We don't need it. All right, so in our collision script, we need to check to see if it collides with the player or the boundary, and if it collides with either of those two things, then it needs to shrink the field as our penalty for missing or getting hit by an obstacle. So what we'll say is void on trigger enter, then we'll make a new variable of type collider, call it other, the other object we're colliding with. So in our onTriggerEnter function right here, we need to start with some conditional checks. We need to say if the other object's tag equals or is player, or the double vertical sign says or, is either one of this condition or other dot tag equal to boundary. If either one of these conditions is true, then we'll perform all the code inside of my if statement. And then we'll say we'll destroy our game object right there. We'll destroy the obstacle when it hits these two things. And we'll also call our shrink function in our game manager, gm.instance.shrink boundary. Remember our shrink function we made a long time ago? Public void shrink boundary? Well, here it is in all its glory. And now we're actually starting to use it within our code to create the kind of gameplay that we wanted. All right, so let's hit Control S and save. We got our obstacles destroying themselves when they hit our player or hit the boundary. And when those two things occur, that's a penalty. So we'll shrink our game field. Why don't we go ahead and press play? Where's my obstacles? What you'll find is I'm going to go ahead and turn off the mesh renderers for my boundary. As soon as you can see them blipping in and out. As soon as my obstacles are instantiated, they're being destroyed by the very boundaries that they're spawning out of. So that's no bueno. We need to be able to tell the obstacles to not be destroyed if it's a obstacle that spawns on the right side. If we have an obstacle that spawns out of this wall right here, we need to tell it to ignore this wall. Don't destroy it and just keep on trucking through the field while still being able to collide and be destroyed and cause a penalty with the left wall over here. So we need to have some more conditional checks to make sure that that logic holds true. All right, so how are we going to do this? Well, first, we need to be able to tell what directions our obstacles are moving. That'll tell us exactly where they are. If we can get the direction of the obstacle, we'll know that if an obstacle is moving from right to left, then the obstacle is going to be spawning on the right wall. We also need to say, okay, if the thing that we're colliding with, if that's the right wall and it's moving to the right, then ignore it. So we're going to do that right now. But before we can really get to the point of, okay, well, testing the direction and the wall it's spawning from, we have to be able to see in our mover function that our hazard has attached to it, the function or the script that is moving our obstacle. It has the move direction variable in it. So we have to get at this direction variable to actually see what direction our obstacle is moving. So what we need to say is, inside of my if statement I've made, we need to create that little variable, the window, into my mover script. So we'll say of type mover, because I'm trying to get to my mover script. And let's just call it mover script equals game object. And then we'll do a get component. And then what component are we trying to get? Less than sign mover, greater than sign, empty parentheses, and close it out with a semicolon. Now my mover script variable has direct access to this component on my obstacle game object. All right. So after we can get to my mover variable, I can now get to my move direction, or after we can get to my mover script, I can now get to my move direction variable, and we can start making some comparisons here. Then we can say, let's do our conditional checks to match the direction and the name of our boundary. That's what we'll use. We'll just use the actual name of the boundary wall, top left, bottom right. And we'll do that by saying if mover script dot move direction equals left and a double ampersand. So both of these conditions must be true for the body of this if statement we're making code to fire off. And the other dot game object, so the other collider's game object that it's attached to, dot name, the actual name of the game object in our hierarchy right here. If its name, and it'll be a string, equals left, then you know what? We're going to abandon ship. We're not going to destroy. We're not going to shrink. So how do I abandon ship out of this whole function right here? Well, there's a simple return statement we're going to make. And that'll keep our obstacles from being destroyed on the left side. So why don't we test that? There we go. You can see I had an obstacle spawn from left to right, and it's destroyed. But other obstacles that were being spawned amongst other walls are still being destroyed and shrinking my playing field. And that's no good. Why don't we go ahead and create the logic for that? We just need to finish that up. So we're just going to copy this line of code. We already have the groundwork. We need to change a few things. So if the move direction is going from right to left, and the thing it's spawning from is the capital R, if the collider wall, the other game object's name is right for the right wall, then we'll abandon ship of this return statement. And we just need to do that for the remaining two directions. All right, we'll say up and if it's spawning on the top wall, so my top wall right here, notice that correct and really good naming conventions on our objects and our hierarchy is coming in real handy right now, because we're actually using those names to define some logic. So if the obstacle is moving down and it's colliding with the bottom wall right here, if it's moving from down to up and it's and it's colliding with the bottom wall, that means this obstacle will be spawning on the bottom wall, and it's moving from down to up, so we'll just return abandoned ship, skip all the code below. We won't hit the destroy function, and we won't hit our shrink boundary function. All right, so we'll hit Control S to save that, and look what happens now. Perfection. And notice how our obstacles are able to hit the opposite wall. And since we're calling our shrink function in our game manager, the obstacles are actually working as intended now. We're actually starting to see a game come alive. All right. But one thing's missing. I can't shoot down my obstacles. My bullets are having no effect. So we need to add that little bit of logic there. So we'll just come underneath my if, my top if right here. And why don't we make an else or an epsiloid particle emitter, whichever one you want. Else if other.tag equals bullet. Then we'll just destroy our game object. So this says, okay, I'm not colliding with the player or the boundary currently. I'm just kind of floating around in the middle of the field. But I have hit the bullet. The bullet, oh God, I've just collided with the bullet. I'm going to kill myself now. Boom. Now we've destroyed our obstacles, and they can't collide with the other wall. Oh God, this game's harder than it looks. So there we go. That is our obstacle collision script to a T. All right, the next thing we're going to do is we're going to create our power-up collision script. And this one will go a little bit quicker because we already have a nice framework from our obstacle collision script. Since power-ups and obstacles kind of function the same way from spawning out of these walls, we're going to use that same ignore that wall kind of logic that we just made for our power-ups. And to do that quickly, I'm just going to duplicate my collision obstacle script right here. So I'll just duplicate it. But now I need to go in and make sure I'm naming it right. So we'll call it collision power-up. I'll copy that whole script name because when I open it up, I need to change its public class name at the very top right here to collision power-up. And we're good to go. But we still need to assign it to our power-up prefab. So let's go back into my game scene. All right, so I'm going to go to my prefabs folder, select my power-up prefab that's in the dugout right here. And why don't we go to add component scripts, and we're going to add our collision power-up script to it. So now my power-up has its own collision script. But we need to come into my collision power-up script and edit some things, because right now it's behaving as if it was a hazard, since we duplicated our obstacle, or my collision hazard or collision obstacle. I call them hazards, but I guess I've also called them obstacles. So it's basically behaving like an obstacle right now is what I'm trying to say. So we need to edit a few things. We need to look at this first if statement. All right. We don't want the power up and the boundary. Let's see, what does this power up have to do? All right. When it hits a player or a bullet, then we're going to fire off, a special power up function, right? When it hits a player or a bullet, that's good. We don't want it just to destroy and do nothing. We want it to do a little something extra special. So it's the opposite of our obstacle. So we're going to get rid of that other tag player, and we're just going to focus on the boundaries right now. And since we already have our script set up for boundaries to ignore the wall if it spawns from the left wall and it's going from left to right, that's good. What we're also going to do next is we're going to get rid of this shrink boundary function right here. And this whole if statement, all it's going to do is destroy a power up if it travels the whole distance and collides with the opposite wall. It's not going to give us anything special. It's just going to destroy itself. So some of the extra logic we're going to have to do is next in our else if statement. So if our power up hits bullet, that's good. And we're going to give the ability for the player just to kind of run into it. So we'll say other tag equals player. That's good. So yeah, it will destroy itself when it hits the player. But it's also going to do something a little bit extra. So I got to make some brackets because I got to add an extra line of code. And right now, we really haven't made any functions for how the power-ups are going to behave in our game. So why don't we just make a placeholder power-up real quick inside of my game manager. But first, I know I'm going to make it, so I'm just going to go ahead and call a gm.instance. And let's just say that I'm going to make a function called power-up. And I'm going to call that guy right there whenever he collides with the bullet or player. So before I forget about it, I'm going to open up my game manager script right here. So here's my shrink boundary function and the shrink little shrink function that works with it. So underneath my shrink function, I'm going to say public void power up. Let's go. All right. So I've made my power up function, and we're just going to use a temporary placeholder function by using a debug.log, and we're going to say power up collected. It'll be up to you to decide what happens whenever we collect that power up. Does it grow the field out a little bit? Does it make you invulnerable? Does it make the hazards not do anything? Does it just pop up a message and say, hey, you're doing pretty good, guy. I believe in you. Whatever it's going to do, this is where you'll describe that logic. But for right now, it's just going to print out a boring little message in our console window that a power up has been collected. All right. So I don't see any errors here. So let's play the game. Looks like our power up is ignoring our player. So let's go back to my collision power up and see why. Bullet. We have a little bit of a logic error with our topology here or whatever. We don't want it both. What I have here in this else if is saying the only way we're going to destroy this game object and get the power up is if it collides with both a bullet and the player at the same time. So the double ampersand says that has to be true and we have to collide with the player. So that's obviously false. What I wanted was an or. Either we either the power up collides with a bullet or it collides with the player. And then we get that good stuff. Before it wasn't doing anything because it needed to collide with both the bullet and the player. So that would have been really tricky, I guess. We would have had to have, I guess, shot right as the power up was coming over the barrel. Not very good. Boom. Power up has been collected. Let's see if I can shoot the next one down. Game testing. Boom. Shot the power up. Second power up has been collected. And you know what, guys? We are playing a game now. It's a very crude game. There's no score or time. The presentation's very bland. Our power up doesn't do anything. There's no start menu, but we are playing a game with game mechanics and everything. Oh, how long do you think it'll take before we just die? Oh, okay. As the objects spawn closer, I'm dying. This is hopeless. So yeah, I've just lost the game. Boom, right there. It's boom. I'm dead. And that is core gameplay now added to the game due to really good object collision. All right, so the rest of these videos are going to be dedicated to refining the game, giving more giving direct control or finer control to the designer to add balance to the game, to create UI elements to make the game, I don't know, a little bit more fleshed out, to be able to communicate to your player what's going on. Maybe even a title screen, so you can start the game. And we'll even see how we can add 2-player capability to the game. So that's kind of like the second half of this series here. All right, so I hope you guys have enjoyed making this game so far. And if you have any questions, just let me know.